Hello everyone, am I audible? Yeah, guys, am I audible?
Yes, sir.
Okay, so let's start. So we were studying about maxima and minima, and we were majorly focused on how can we find out the point of minimas and maximas, which means that we want to find out the maximum and minimum value of the function y, and we also want to find out the value of x at which this maximum or minimum value exists, right? And we talked about it in the earlier class, and we discussed about the core crux or the core concept of this, like how can we find out. So one method that we have discussed is that if we know uh, the nature of our function, whether it's increasing or decreasing, then we can certainly identify these extreme points, right? And if we are able to identify them, then we will be able to find them, right? So a better way, or rather our approach should be to know about whether the function is increasing or decreasing. If the function first increases and then decreases, then it gives us a point of local maxima, and which makes sense, right? Because first it is increasing, it increases up to a certain point, and then after that point, it start decreasing. So that point should be maximum in its neighborhood, right? And if our function is decreasing first, and then after decreasing, it's increasing, then it will certainly give us a minimum, like you can observe in first or second case, right? These examples that I've shown. In the second case, you can see that function was first decreasing, function was decreasing in second quadrant, and in the first quadrant, function was increasing. So it gave us a point of local minima, right? Which was actually the lowest value of this function at all the points in its domain. So that is why we can also call this point as global minima, right? So this, if a function decreases first and then increases, then it will give us a point of local minima. That these things or these relationships or these rules, we were able to identify them in the last class, right? Just give me a minute. Yeah. So we were able to establish these relationships in the last class. Let's start from the point that we have uh, left in the last class, and that is how to find out these points of global minima and global maxima using this method, right? So for this, we already know the approach, how to find out extreme points, and this is also known as first derivative test, right? And first derivative test basically helps you in finding out all of these turning points. Now, how can you find these turning points is, just give me a minute. Right? Yes. So let's discuss this approach. Just revise the approach. For what will we do to find out these turning points? Is we will try to find out when is the sign of f dash x changing, and for that we will go with our wavy curve method only. Consider a function y is equals to fx. We will find out f dash x, and then we will try to find out the signs of f dash x, right? When it is positive or when it is negative, that we can do by wavy using wavy curve method. And after that, the points or the roots in the wavy curve method will tell you, I mean, those will be the points of, those will be the points which we are interested in. And these points will be known as turning points, right? Let's move forward with the question that will certainly clarify the approach that we need to take to solve this. Okay, let's find out this. Find out all the points of local minima and local maximum. Find all points of local minima or maxima right, of the function f Okay, so let's take first question, which is we need to find out when will this be local minimum or maximum in its domain. So always remember that whenever we are talking about polynomials, and you, I mean, you should know by now what are polynomials. If not, then you can ask me whenever you are confused about which type of expression is it. You can directly ask me. So this is a polynomial. And whenever we are talking about polynomials, the domain will always be from minus infinity to plus infinity. This is fixed. For polynomials, your domain will be all real numbers. All real numbers mean minus infinity to plus infinity. You can give any value from minus infinity to plus infinity to all the polynomials, right? Sure, let's start with finding out the minimum, local minimum and maximum of this function. Shahid, am I audible? Shahid, am I audible? I think you are joined now. Please feel free to ask me if you are facing any problem, okay? Okay, good. So I just told that if we are dealing with polynomials, then your domain is always fixed. You can give any value to x. You can put any input in the polynomial, okay? So in the case of polynomials, your domain will be, yeah, I understand. Yeah, I know. You got disconnected. That is why I'm repeating this. In the case of polynomials, domain will be always real numbers. Just remember this, okay? Because there is no problem of domain, right? Because all the polynomial functions do not have denominator. So there is no point of that. I mean, first condition will be invalid. The denominator should not be equal to 0. As there is no denominator, there is no point of asking it to be not 0, right? And the second point was for domain, we consider second point was square root. There should be no non-negative value inside the square root, right? There is no square root in the polynomial, so that is why that condition will also be not valid. And because of that, polynomials will always have the domain all real numbers. Okay. Sure. Let's start with finding out the local minimas and maximas for this. So for this, we need to follow these steps. We have already written the algorithm. Okay. So to solve this, first of all, find f dash x. F dash x would be 3x squared minus 3, right? Now you have to check the sign of f dash x. Check the sign of f dash x using wavy curve. And to apply wavy curve, you know that you have to first factorize the whole expression. So I want to understand when is f dash x greater than equal to 0 and When is f dash x less than equal to 0? This is my question. I want to understand when f dash x is positive and when f dash x is negative, right? And we know to solve this, what do we need? We need the wavy curve method. So we can start by solving any one, and it's not a, this is what we are interested in. Because that will directly tell us when fx is positive, when fx is increasing and when fx is decreasing. So let's start applying wavy curve to it. For applying wavy curve, we have to factorize this. So take 3 common, this would be x square minus 1, and x square minus 1 can be further factorized into x minus 1 into x plus 1, right? X minus 1 and x plus 1. Now I want to apply wavy curve. For wavy curve, we should have this inequality, right? We have discussed about this, that we should, if we have an inequality, then wavy curve will be applied. But we don't have any inequality here, right? Matlab, we are not using the inequality directly, but we do know that we need that inequality because we want to understand when f dash x is positive and when f dash x is negative. It means that we are interested in the sign of f dash x, right? And for that, we know how to apply wavy curve. So first we will factorize the whole expression. Now we will identify the roots of this expression. There are two roots. One is -1 and second is 1, right? -1 and 1. Now we will understand if the coefficient of x is positive or not. Both the linear factors have coefficient of x as 1. So no point of negative coefficient. Now after this, we will start with the sign which is outside the expression. In this case, the sign outside the expression is positive. We will put positive in the rightmost interval, negative, positive. We will start from rightmost interval. From rightmost interval, we will reach to the leftmost interval by alternately changing the sign. Right? Now we know that, what is the sign of f dash x in different intervals? First of all, there are 3 intervals in which we can judge the sign of f dash x. First interval is -∞ to -1, in which f dash x is positive. So whole of this understanding tells me what? I now know f dash x is positive, right, in the interval -∞ to 1. F dash x is 0. F dash x is 0 at x is equals to -1. Right? These are my conclusions. Right? This is basically the report of above test. Then f dash x is negative, less than 0, when x is from -1 to 1. I'm using open intervals, right? Why I'm using open intervals? Because I'm saying f dash x is less than 0. If I say f dash x is equals to 0, then f dash x is 0 at x is equals to 1 also. So f dash x is 0 at x is equals to -1 as well as at x is equals to 1. Now fifth, f dash x is again positive in the interval 1 to infinity. Right? If f dash x is positive, it means that fx is increasing. In this portion, fx is increasing. If f dash x is less than 0, it means that fx is decreasing. But again, in this interval, fx is increasing. So as the sign changes from plus to minus, that is, first it was increasing and then it was decreasing. So it was increasing like this, right? And after this point, it starts decreasing. Then clearly after this point 1, it starts increasing. You can observe the graph. This is 1 at x is equals to -1, sorry. This will give me point of local maximum. And this will give me point of local minimum. right? So I can clearly see that my f dash x is changing the sign. It definitely means that I'm getting some extreme points. Now, if it changes the sign, as many times the f dash x changes sign, that will be the number of extreme points directly. So if f dash x is changing the sign twice, it means that you are going to get two extreme points. And you can observe here, first f dash x was positive, then it was negative, then it was again positive. So it changes two times. That is why we got two extreme points. One is point of local maxima, another is point of local minima. Right? We can also find out the value of fx at these points. Okay, so we want to understand what is the value of fx at x is equals to -1. You are saying that this is the point of local maxima, right? We want to understand what is the value of fx at x is equals to -1. So fx is x cube minus 3x plus 3. Okay. Just a minute. It means you can find out f minus 1. And f minus 1 in this case would be -1 cube, right? Which is -1 plus 3 plus 3, which means that f minus 1 is equals to 5. So your local maximum value would be 5. If you check any point around -1, you take -1.1 or you take -0.9, right? A point greater than -1, but in the proximity of -1 only, then you will observe that there is no value which is greater than 5. All the values will be lesser than 5. If you put x nearby -1 in this function, the greatest you can get is 5 at x is equals to -1. Similarly, we can also find out the values at 1. So f1 will be 1 cube, which is 1, minus 3 plus 3, which is 1. Hence the local minimum value would be 1 and local maximum value would be 5. If you observe, if you put any value around 1 in this case, you will always get a value greater than 1. So if you put 1.1 or if you put 0.9, in both the cases, you will get the answer greater than 1. You can check that as well. Okay, please note this down and start asking me any question if you're facing any doubt. Yeah. So is it clear to everybody? How are we going to
Can you show
find
the
out?
question?
Sorry.
Sir, can you show the question?
Yeah. This is the methodology that we are going to follow for some time now. And then we have another strategy to by which by which we can also find out these extreme points. But first understand this thoroughly. I'll also tell some of the steps that we can actually perform better in this case. But this was the first question. That is why I have showed you the full solution also and full method. But you can see that we can directly observe one thing. Wherever f dash x is zero, wherever f dash x is zero, these are the, if you observe, these are the critical points. F dash x was 0 at -1 and 1. Both of them are critical points. So my first question is, I mean, not the first question, but my first inference from this question would be, inference my first conclusion from this question would be, wherever f dash x is 0, these points are important. We can, I mean, these points have the potential to be an extreme point. Now the question is, will they always be extreme point? No. They will not be, no, I mean, always they will not be the extreme points. In some cases, these points at which your f dash x is 0 may not work as the extreme points that we are looking for. We will also cover those examples, but the general method would be this. We will find out f dash x and we will apply wavy curve on f dash x. That will clearly give us the picture whether this point is a local maximum or this is a local minimum or not. Whatever happens, that point will certainly give us very clear picture. I mean, wavy curve will tell us everything. Anji, is it done, everyone? If somebody is writing, just raise your hand. Okay. So then I think this is a very fun method, by the way. मतलब पूरा maximum minimum funny है. First of all, the questions बस एक बार, but थोड़ा theory lengthy है. इतना नहीं है कि it's not like we only have this method and do not have any varieties in this. There is a lot of variety, but all the varieties, all the different type of questions will be fun only. So let's go through the basics, and then we will have word problems, which will be very interesting actually. Some of the word problems you will not be able to solve though, but they will be interesting nonetheless. Questions can be really tough in this maxima and minima particular area. I mean, this we teach in the engineering mathematics also. So this is a broader topic actually. There are a lot of things that you don't know yet about maxima and minima. So the questions can be really tough. But in our syllabus, the questions are fun. Questions are tough also, but they are fun. Sure.
Is a second derivative test necessary?
Yes, there is second derivative test too. But that we will understand in a bit. First, let's try and let's understand this method first. So then, in the series of this, second question is, we have to find out, and also I would like to update the question actually. Find the points of local minima maxima of the function f given by this, and also find the minimum and maximum value. We have to find out the points of local minimum and maximum, which is in this case x is equals to -1 and x is equals to +1. x is equals to -1 is the point of local maximum, and x is equals to +1 is the point of local minimum, right? And also the minimum value of f is 1, local minimum value of f is 1, and local maximum value of f is 5. So we have found out all the things, and in the subsequent parts, we have to solve the question like this one. Right? So your second question is this: you already know about wavy curve. You just understood a new application of wavy curve. Let's apply this in some questions now. I'm expecting answers from everyone, so please participate in this because you can't leave this. ये यार काफी दूर तक चलता भी है, मतलब graduation में भी पढ़ा है मैंने, and in fact I told you guys that I am in an Indian Statistical Institute. तो यहाँ पे भी in the entrance, for the entrance of the college, I gave the exam, and in the examination I received 2-3 questions from maximum and minimum. In fact, there is a word problem, full-fledged word. There was a full-fledged word problem, which was in your syllabus only. पूरा 12th का syllabus से ही वो question था. अच्छा question था, थोड़ा tough था, but हाँ, syllabus तुम भी solve कर सकते हो, same question. ऐसा नहीं है कि कुछ उसमें अलग था. It is a very fun portion. Try to engage. और अगर तुमने सही से वेवी कर्व पढ़ा है तो तुम्हारे आंसर्स आने चाहिए, मतलब इसमें कोई बात ही नहीं. और यार जितने भी लोग आईआईटी वाईटी का सोच रहे हैं, भाई वेवी कर्व तो बहुत ही बेसिक मेथड है. मतलब मैं तुमसे ये बता दूं पहले तो, मतलब वेवी कर्व में भी कुछ और वेरिएशंस हैं. मैं ऐसा नहीं बोल रहा कि अभी तक हम पूरा वेवी कर्व जानते हैं. ऑल्दो मैंने तुम्हें ऑलमोस्ट पूरा ही वेवी कर्व कराने की कोशिश की है. तुम्हारे सीबीएसई बोर्ड के सिलेबस के अकॉर्डिंग तो हम बहुत ज्यादा वेवी कर्व पढ़ चुके हैं. तो now Austin, this is not for you. I believe that you already know the wavy curve well. So I was telling them about the importance of wavy curve. तो यार आईआईटी वाले स्टूडेंट्स को तो वेवी कर्व मतलब ऐसे बिल्कुल बहुत ही अच्छे से आना चाहिए. इनफैक्ट तुम वेवी कर्व और जगह भी लगाओ और बताओ मेरे को, तुम्हें कुछ डाउट्स आएंगे, मैं वो भी सॉल्व करा दूंगा. लेके आओगे तो क्वेश्चन, और क्वेश्चन तुम्हें लेके आने पड़ेंगे. लेके आओ और मुझसे पूछो. मतलब मेरा मतलब ये है कि अगर तुम सॉल्व कर रहे हो तो लेके आओ, कहीं भी फंसते हो, क्योंकि वेवी कर्व तो बहुत ही बेसिक मेथड है. बहुत ज्यादा यूज होता है वेवी कर्व का. आईआईटी के सिलेबस में तो बहुत ही ज्यादा यूज होता है. मतलब कोई बात ही नहीं है इसमें सोचने वाला. तो इसलिए वेवी कर्व लगाना सीखो सही से. नहीं आता अभी तक भी तो पूछो मुझसे, कोई दिक्कत नहीं है, बट सीखना पड़ेगा. ये इंपॉर्टेंट है काफी. वी यूज फर्स्ट डेरिवेटिव टेस्ट more than the second derivative test usually. That is why it is important to understand the wavy curve method thoroughly. Sorry, it's not f dash x. My bad. This is only f dash x. Oh, sorry, fx. There's a function fx is given to you. You have to find out the point of local minima and point of local maxima, and also the value of function, the minimum value of function and maximum value of function, whatever exists. Anji, what is f dash x? Let's go through step by step. Whenever you find out f dash x, any one of you, please feel free to speak or mic on करके. Don't
6x square minus 12x plus 6.
Acha. Can we factorize this more further?
1 minute, sir. Yes, sir, we can divide by 6 and then x minus 2.
We can take 6 common, right?
Yes, sir, 6.
Then it would be x square minus 2x plus 1.
Yes.
X square minus 2x plus 1 would be x minus 1 whole square, right? Everybody clear up to this part, right? Now, what is your comment on this? Can we apply wavy curve? I mean, we can certainly apply.
Yes, sir, we can.
Yeah. But what should be the result?
Minus infinity to 1, 2, more than.
Yes, right. There is a root and the root is 1. So we have two intervals, minus infinity to 1 and 1 to infinity. What is wavy curve doing here? You understand this. What is wavy curve doing? Wavy curve is first dividing. Wavy curve is first telling you how to divide the minus infinity to plus infinity wala interval. Like, what intervals do you need to check for this particular function? And what is the value of the function in those particular intervals? And how do you check that? You simple find out the roots of f dash x. How do we find out the roots? By factorizing. So that is why we are factorizing. We factorized, we find out roots. Now we put those roots in number line, and now we try to identify what is the sign of this function in these particular intervals. For that, we have created a direct algorithm. हमने आपको समझाया कि भाई x का कोफिशिएंट पॉजिटिव रखो. ये जो सब हमने स्टेप्स कराए ना इसमें, x का कोफिशिएंट पॉजिटिव रखो, राइट मोस्ट इंटरवल से स्टार्ट करो, देन लेफ्ट मोस्ट तक आओ, बाय ऑल्टरनेटली चेंजिंग द साइंस. ये पूरी एल्गो जो तैयार करिए, ये इसलिए करिए कि आपको ये ऐसे जाके रख के चेक ना करना पड़े. I mean, what is an alternative approach to wavy curve? We would check by ourselves in those particular intervals. Like, for example, in this last question, okay, in this last question, as soon as we find out the roots minus 1 and 1, so what can we do? Rather than using this algo, what could have been done was we take some value from minus infinity to minus 1. Okay, we take some value of minus any value. Let's say we are taking minus 4. Okay, so as soon as we take minus 4, we put this value in the given function f dash x. Minus 4, if you put minus 4, this is negative. Oh, okay. If you put minus 4, so if you take minus 4, right, and if you put minus 4, this is negative, and if you put minus 4 is here also, this is negative, then the sign is positive. So now, instead of using this algorithm, what we can do is we can first find out the roots. We take those roots and put it on the real number line, right? And that will give us an interval for this particular function, that you have to check this function in these intervals, right? Now, either you can follow the algorithm that you have learned, or you can yourself do this, that you take a certain value from the given interval. Like in minus infinity to minus 1, I have taken minus 4. You put that value here and you observe the sign. Whatever the sign is, that will be the exact sign that wavy curve will be giving you. See, the sign is positive. Wavy curve also said that this interval is positive. So sign of f dash x in this interval is positive. Similarly, you take any value from minus 1 to 1. Let's take 0. The sign would be negative. You can observe that. Okay? And take any value from 1 to infinity and observe the sign. Okay? That is how we can perform. That is how we can alternatively perform wavy curve. This is what I'm telling you. This is the exact job of wavy curve. That जो भी मैंने अभी तुम्हें बताया वही wavy curve करता है बिल्कुल. It takes a point from a certain interval. It find out the value, right? But that algo is done just जैसे मैंने तुम्हें बताया वो बिल्कुल वैसे ही कर रहा है. It works like that, right? Now in this case, or we have also learned the rules of wavy curve, that even powers को छोड़ देते हैं, ignore the even powers, right? Everything. So either you learn thoroughly wavy curve, which we have already discussed. So you will observe that this is x minus 1 whole square. This is actually even power. You can't apply wavy curve here. I mean, wavy curve is telling you that this sign will be positive always. Or you can apply common sense that this is 6 times x minus 1 whole square. If this is x minus 1 whole square, whatever you put the value of x, this whole square becomes positive. This is always greater than 0. In fact, greater than equal to 0. There is only one point. There is only one point at x is equals to minus 1. Your f dash x would be 0. Your f dash x would be 0. Right? But as the value of f dash x, as the value of f dash x is always positive, there is no point of local minima or local maximum. Right? This is a monotonic function, if you remember. This is a monotonic function. Monotonic function. always strictly, not strictly, but yes, always increasing, increasing. This is an increasing function. Hence, it does not have, yeah, right. There should be x is equals to 1, not x is equals to minus 1. Correct. That is why no extreme points. Or we can say no point of local minima or maximum. Because our f dash x is not changing the sign. It changes its sign 0 times. That is why 0 extreme points. No point of local minima or local maximum. Yeah, everybody's clear by far? Please feel free to ask your doubts. कहीं पे भी प्रॉब्लम है पूछो. क्योंकि अभी मेरी प्रॉब्लम्स आना स्टार्ट होंगी. I'll ask you questions. This is a very interesting topic, right? No? I mean, everything is mechanical. If you see, there is a mechanical process. We are telling you everything about this. There is a rule. You have to follow the rule. But there is also an explanation for every rule. There is also a logic. There is also a reason behind every rule. So either you can go through rule or you can go through logics. The point we want to understand is the sign change of f dash x. Whether f dash x is changing its sign or not. And if yes, then what are the intervals in which f dash x is changing its sign? Right? In this case, f dash x is always positive because 6 times x minus 1 whole square. It means that f dash x is always positive. Means what? F dash x is an increasing function. And if a function is always increasing or always decreasing, then we say these functions are monotonic functions. So this fx in this case is a monotonic function. And there is no point of local minimum or maximum. But now there's a very interesting another insight involved in second question and first question. In the first part, we saw that whenever f dash x was 0, f dash x was 0 at 2 points, x is equals to minus 1 and x is equals to 1. They were point of local minimum and local maximum. Right? They were extreme points. But in the second part, f dash x was 0, but still it wasn't an extreme point. So what is this point? What does this, what did this do? What was the point of this point, having this point? Okay, for this, to understand it better, what is f dash x is equals to 0 shows actually, it gives us a list of numbers. It gives us some types of numbers, right? In which one type can be that if for a function fx, if your f dash x is 0 at certain x, right, then these values of x can be extreme points. They can, I mean, they may not be an extreme point, but they have the potential to be an extreme point. If your f dash x is not 0 at some x, then it is sure that that point is not extreme point. Understand the difference again? If f dash x is 0 at some point, then this point can be an extreme point, right? But if f dash x is not equal to 0 at some x1, let's say there is a value x1 and f dash x is not 0 at that value, right? Then you can certainly identify that value as a non-extreme point. This point will never be a extreme point. So this is an important information. Yeah, now we will talk about what does f dash x is equals to 0 signifies. If we have, I mean, in fact, rather than that, you would be more interested in, just give me a minute, guys. Let me search something. Okay, we have There is another point of there another point which is very important and considerable here, which is point of inflection. So let's understand this thing, and then we will be able to explain the logic of what happened in the last case, right? Let's take this example. Y is equals to x. So first of all, I would like to show you the graph of y is equals to x. And y is equals to x cube, something like this. Not like, but yeah, you got the shape. I mean, this is something like that. Yeah. So this is the shape of y is equals to x cube. Now observe this point, x is equals to 0. If you see y is equals to x cube, or rather fx is equals to x cube, you can also write it like this. And now if I find out f dash x, the value is 3x squared, right? And if you try to apply wavy curve here, then it says that 3x square is always greater than equal to 0. Right? 3x square is always greater than equal to 0, which means that fx is monotonic, increasing. Now, but still, it says that f dash x is equals to 0 at x is equals to 0. So what happened at x is equals to 0? What happened at x is equals to 0 is it changed concavity. Now this is a new word, and by the way, you don't need it for CBSE boards, but still I'm telling you this concept. It's a very easy concept, but concavity change. Concavity change is money. See, if you draw a tangent at any point on this curve, y is equals to x cube, this is the curve of y is equals to x cube, right? And yeah, I will tell you, Shavis, but first of all, understand this. If you see this curve is divided into two parts. One part is this lower part, this whole part, lower part, right? And one part is this upper part, which is lying in first quadrant. So this curve actually lies in first quadrant and third quadrant, right? Now, if you draw a tangent of this curve in third quadrant, the tangent will be this. This will be a tangent at this point. Let's say I'm drawing a tangent at this point. Every time you draw a tangent on this curve in third quadrant, the tangent is above and the curve is lying down the tangent, right? But every time you draw a tangent here, every time you draw a tangent here, you can see that the curve is above and the tangent is below, right? So in this case, your curve above, tangent below. But in these cases, your tangent is above and your curve is below. And for intuitive sense or for your logical to understand what is happening, these are two shapes, right? One shape is like this and one shape is like this. Both are increasing. Both are increasing. Basically, these are two shapes. You understand these two shapes. These are two shapes. Both are increasing, but both tells you the different rate for increasing. One may be slowly increasing and one is faster, right? So this basically tells us this thing, whatever we have discussed, that whether the curve is above and tangent is below, or the tangent is above and curve is below, this basically tells us exact same thing is known as concavity. Concavity, either the shape is concave or the shape is convex, right? This is what concavity says. Either the shape, yeah, you must have studied convex and concave surfaces in physics, right? So this is what exactly tells us that whether the shape is concave or convex. This is what concavity tells you about a function, how to draw the graph of a particular function. So this is known as concavity. When the concavity of a graph changes, right? When the concavity of the graph changes at some point, that point is known as point of inflection. So basically point of inflection का मतलब ये है, अगर मैं तुम्हें बहुत ही layman terms में, if I explain this in layman terms, that point of inflection basically tells you whether the graph is slowly increasing or fasterly increasing. This is the fastly increasing. This is the point of inflection. Point of inflection माने कि ग्राफ तुम्हारा बदल जाएगा शेप में, वो ऊपर की तरफ कॉनकेव शेप है, कॉन्वेक्स शेप है, तो इन्फ्लेक्शन भी यही होता है, कॉनकेव शेप या कॉन्वेक्स शेप, right? And this is what so one thing is concave upward and another is concave downwards, right? So whenever you're it's a very simple rule, by the way. Whenever your uh, curve will be above and tangent will be below, then it is concave downward. You have to take the sign of tangent. अगर tangent नीचे है तो concave downward. If tangent is above, then concave upward. Concave downward and concave upward. For concave downward, your d2y by dx square would be positive. Simple, the slope of this tangent. You can see that the slope of this tangent will be the angle made with x-axis. Angle made with x-axis is this, theta, for this tangent. And this theta is lesser than 90. So basically, this theta is, tan theta will be positive. So graph for the slope of this line, tangent, is positive. That is why d2y by dx square is positive for this function. Or you can see that f double dash x would be positive for this. And here, your f double dash x would be negative. Why? You can observe this. These kind of functions will give you a negative value. क्योंकि यहाँ पे हमारा एंगल जो होगा वो 90 से बड़ा होगा. The angle will be greater than 90. You can see this is the angle. This angle is greater than 90. That is why f double dash x is negative. But this is what concavity downward and concavity upward means. So these points basically tells you. So now this point of inflection, why did I tell you about point of inflection? Point of inflection will also exist when f dash x is 0. So if your f dash x is 0, then that point either can be a point of inflection, right? Or an extreme point. If f dash x is 0 at some point, it means either that point is point of inflection or that point is an extreme point. Now, how do we check for point of inflection? So in these cases, by first derivative test, you can see that the value of f dash x would be 0. How to check? The important point is this, how to check. क्योंकि अगर हम निकाल ही नहीं पा रहे पॉइंट ऑफ इन्फ्लेक्शन और पॉइंट ऑफ एक्सट्रीम मतलब एक्सट्रीम पॉइंट्स दोनों को अलग अलग नहीं डिफरेंशिएट कर पा रहे और निकाल पा रहे हैं तो फिर क्या ही मतलब वो तो पूछेंगे हमसे यही एग्जैक्टली वो यही जानना चाहते हैं कि डू यू नो द डिफरेंस how do you find out extreme points and how do you find out the point of inflection. So for this understand this, okay, by first derivative test how do we find out whether this, okay, so first of all also understand critical point here. Also understand critical point there. This is also very important. This will give you a more clear picture. These points are prime importance, critical points. But what are critical points? Before that, understand this. What are critical points? So critical points is a collection of all those points. It is a collection of all those points. Now, if you have a function fx, right, and for fx, you want to find out critical points, then these, I mean, a point, if a point is a critical point, then it needs to be, fulfill some conditions, and these conditions are the collection of all those points. Which satisfy either of the the first condition is if my f dash x is 0, at any x, then that x is known as your critical point. So if your f dash x is 0 at any point, then you say this is a critical point. So every point of inflection which you have studied, or extreme points, point of local minima or point of local maxima, everything is a critical point. Critical point माने यार ये point important है. This is an important point, right? Simple meaning है critical point का. So if a point is critical point, then it means that the point is important. And how do you find out critical points? So it is a collection of all those points which satisfy either of the given conditions. And first condition is f dash x is 0. Then second condition is f dash x does not exist. If your f dash x does not exist. So for example, I'll also provide you this example. If f dash x is 0, then either this point can be an extreme point, or this point can be point of inflection, which you have already seen, right? Extreme point also and point of inflection. Now, second condition is f dash x does not exist. F dash x does not exist. Now, I'll show you an example. So let's say my expression for f dash x is 4 by x minus 1 whole square. Or rather, I would like to change this expression. So let's say my expression is f dash x is equals to x minus 2, x minus 3 divided by x minus 1 whole square. Right? Okay. So point of inflection. Okay, I'll come to that point. Okay, sure. Give me some time. I'll come back to that point. But first of all, understand these critical points. Okay, this is also important. So critical point is a collection of all those points which satisfy these three conditions. First condition is f dash x is equals to 0. If your f dash x is 0, it will be said a critical point. And if your f dash x is 0, it can further signify, or it can be further classified into 2 points. Either it can be extreme point or it can be point of inflection. Right? We have already understood extreme point. We have also understood point of inflection, but I will revise that. Give me a minute. And now the second condition is if your f dash x does not exist. So for example, I've shown you an expression of f dash x, and f dash x is x minus 2 into x minus 3 divided by x minus 1 whole square. So let's find out what are the points, what are the critical points here. Okay. So critical points will be collection of all these points where your f dash x is 0. So f dash x is 0 at x is equals to 2. If you make this 0, then your whole expression becomes 0. And if you make this 0, then also your whole expression becomes 0. So critical points are, in this case, critical points will be 2 and 3 directly. Now, also, if you put x is equals to 1, you understand this. If you put x is equals to 1, then your whole value becomes not defined. Not defined means it does not exist. Infinity. Everything is same. Okay. So this x is equals to 1 is also a critical point, because this is telling you something about the function. So critical point is basically those points which are telling you something about the function. These points are important for that particular function. Now, how they are important? Because they are telling you something about that function, something critical about that function. These points contain some information about that function, right? Now, these informations, what are these informations? वही हम तुम्हें बता रहे हैं. These informations are either it can be an extreme point. What is the role of extreme point? You know that it will give you either minimum or maximum value of the function. It can be point of inflection. What is the role of point of inflection? We have just told you that at point of inflection, the graph of the curve changes. I mean, curve of the function changes. How does it change? It changes its concavity. So what is concavity? Concavity means if you draw the graph and if you draw a tangent on the graph, then where does that tangent lie? Whether your curve lie above or whether your curve lie below the tangent. If your curve is lying above the tangent, in that case, you say that curve as concave downward. If your curve is lying below the tangent or your tangent is lying above the curve, then you say concave upward. Right? So concave upward and concave downward basically tells you the rate of increasing. Either the function is increasing fast or the function is increasing slow. Function is increasing, certainly increasing. दोनों ही केस में फंक्शन इंक्रीजिंग है, बट फंक्शन इंक्रीज तेज कर रहा है या धीरे कर रहा है? कौन सा तेज कर रहा है? Right? We also want to understand the speed of increasing. So that is what concavity helps us with, and point of inflection helps us with. And if your if your function is changing its concavity, then all those points where the function changes its concavity will also provide you f dash x is 0 at those points. But in these cases, your sign of f dash x won't change. Your sign of f dash x won't change. Your f dash x would be 0, but sign of f dash x won't change. As you have observed in this second example. यहाँ पे आप देख सकते हो साइन चेंज नहीं होता f dash x का, but f dash x 0 हुआ था, right? So these points are known as point of inflection. Now critical points, we were discussing critical points. So first was f dash x 0. अगर f dash x 0 होता है तो either it can be an extreme point or it can be a point of inflection. Second is f dash x does not exist. So if f dash x does not exist, in that case also you call that point as critical point. And third is if fx does not exist. If your function is not existing at some point, that is also critical point, because that is not in your domain. You can't put that point. You can't use that point in the function. Right? So all these points are known as critical points, and critical point, the set of critical point is very important for a particular function. And that is why we are finding out these critical points. We have some classes in critical points, like first class is extreme point, then second is point of inflection, and then these third classes and fourth class basically deals with the domain of the function. So that is how we can define the critical points and point of inflection. Now let's understand, if f dash x is 0, then what do we get? If f dash x is 0, then we will get either extreme points or point of inflection. How do we identify that? We will check with the sign of f dash x. If the sign of f dash x is changing, okay, you can, I'm just writing the logic here in front of extreme point. Okay, so extreme point, how do we identify extreme point? To identify extreme point, f dash x, sign of f dash x must change. Sign of f dash x must change. And for point of inflection, sign of f dash x does not change. Right? Sign of f dash x does not change, but f dash x is 0 in both the cases. Right? So this was all about first derivative test and how to find out the points of local minima and points of local maxima through f dash x. Let's solve some further questions. Okay, we can only solve it this one question. So let's try this one. F dash x. This is fx. Please, everyone, try to solve this one. Okay, try to solve this. X cube minus 6x square plus 9x plus 50. Just third, not the fourth. I'm only asking for third. X cube minus 6x square plus 9x plus 15. This is for homework. And also I'll send some questions. You will get the homework. So also solve these questions. And no, extra class. So I guess we'll be done. Can you have an extra class on Saturday? Because I'm not sure. In the next week, I may not be able to take any of the class. I don't know. I have 4 companies. So it may not be possible that I'm available. So in that case, we should have an extra class on Saturday because both the classes can be cancelled on Monday also and on Wednesday also. दोनों दिन यार companies हैं. मतलब in the next week, my next week, whole of the next week is packed with the companies. So what is f dash x, Austin, in this case? Tell me that. Okay, in that case, I would like to just tell you this thing also. Extra class on Saturday. Just before your regular class, 6:30 to 8. Okay, sure. Cool. What is f dash x in this case, Austin?
3x squared minus 12x plus 9.
Right. So we
Yes,
have to factorize this x square minus 4x plus 3. Okay, so to factorize, you have to find out two numbers. To factorize, you have to find out two numbers such that, do you know this method, splitting the middle term?
yes, sir.
Okay, so splitting the middle term says that find out two numbers whose sum is minus 4, whose sum is this minus 4, and whose multiplication is plus 3. So you basically have to find out two numbers, a and b, where a plus b is minus 4 and a into b is plus 3. What are these two numbers? Minus
Sir,
1 and, I guess. Yeah, Shavel.
I got the answers.
बताओ क्या है आंसर?
Yes, sir.
What's the answer? Tell me.
Sir, it's two critical points are 3 and 1.
Okay. And what are these points? Can be classified as? Are they extreme points or point of inflection? And if extreme point, then
They're
which is
extreme
point of
points.
minima, local minima and local maximum?
Sir, one is local maxima.
One is local maxima. Okay. And 3 is local minima.
Yes.
Okay. And what's the minimum and maximum value, local minimum and local maximum value of the function?
That I have to calculate.
Please. Austin, what are the two values? Minus 1 and minus 3, right?
Yes.
Minus 1 and minus 3 adds up to minus 4, and if you multiply minus 1 and minus 3, then you get 3, right? As soon as you get these two numbers, you can directly factorize this. How? Just write these numbers with x. Minus 1 and minus 3, no? Minus 1 and minus 3. If these numbers were, let's say, if these numbers would have been minus 1 and 2, right? Then I would have written x minus 1, x plus 2. Simple.
Yes.
These are the direct factors. Okay. You can directly draw the number line. You can start with positive, negative, positive. You can see that x is equals to 1. Increases, then decreases. Increases, then decreases. And then decreases from decreases to increases. So this is, as the sign of f dash x is changing first of all. So there is a point of local minima and local maxima here. There is an extreme point here. So this is point of local maxima. And this is point of local minima. Okay. You can also find out the value of function f(x) at 1. f1 is 1 minus 6 plus 9 plus 15. This should be 24. 25 minus 6. 25 minus 6 is 19. And then f3. f3 would be what? We put 3 here, 3, 27. 50. So this is local minimum of, or rather local minimum value of fx, and this is local maximum of fx. Right? Now we will end the class for today and we'll meet on I guess Saturday, right? There's no problem in having this extra class, right? Everybody's free.